So yes, thank you very much for having us. I'm with the MicroPython team, and there has been some talks about MicroPython already in this event, which is really great, or CircuitPython. So mostly of them are in the maker sector, or maybe in the education. So I would like to talk a little bit about how MicroPython is already used in industrial applications, where we are involved directly or we know that it's used. So first of all, I give an overview. So is there someone who has never heard of MicroPython before? Yeah, so perfect. So I introduce a little bit what we did and where we are now. Then I go and show you a real product that works with MicroPython, which I generously was allowed to bring here. And I want to share a little bit how we think MicroPython can generate, an advantage for companies if they use it in the product development. And I'm happy to answer some question afterwards about the talk or about MicroPython in general, if you're interested. So let's just go into it. What is MicroPython? It aims to be a lean and efficient rewrite of Python, so it's rewritten completely from scratch. It has a compiler, a virtual machine, a runtime system, a garbage collector. So you can compile to bytecode or native machine code. It supports an inline assembler. And all your compilation happens on a chip, which means you don't have to install anything on your PC. Everything is interpreted on the controller. So you're all Python programmers, so you're very familiar with the REPL. So you can use this like if you're doing normal Python. MicroPython is not completely comparable with Python, but we aim to be as much the same as it is possible. So this seems all like a lot of work, which it was. The creator of MicroPython, Damien George, had the idea in 2013 because he wanted an interpreted language to easily control his hardware devices. And he would really like to have it done with Python. So he thought, maybe there would be other people interested in this, so I run a Kickstarter. And I always wanted to run a Kickstarter because everybody is doing it. So he collected about £100,000 for this initial idea, so the community was very into it. MicroPython was kind of wanted. So with these first initial £100,000, the first batch of MicroPython PyBoards was created, which you see down to the left, so the first 3,000 pieces of these. And since then, we have really come a long way. There has happened a lot. MicroPython is an open source project on GitHub, so everybody is more than welcome to contribute. We have about 6,500 stars and ranking in the top 100 of the C++ projects. So yeah, it's kind of famous. And so in the UK, there was the BBC Microbit project, where in 2016, all the 11 to 12-year-olds got a BBC Microbit where MicroPython can run for teaching. There are already other companies using MicroPython to ship their development boards. You might have heard about CircuitPython from Adafruit, and there are more companies like PyCom or OpenMV who do machine vision. Then, very exciting for us, like a really big milestone is that there's the first MicroPython O'Reilly book coming, like it's already out. Also last year, programming with MicroPython. And we are ready to launch the second generation of PyBoards, which I will go into more detail later in the talk. So when I talk to people about, so Christine, what do you do for a living? And these are embedded programmers. They say, oh yes, Python for microcontrollers. Last time when I checked, Python was an interpreted language. So this is slow. It eats up a lot of resources, and it's not very energy efficient. Yeah, well, they are right. But let me just say MicroPython is fast enough for most tasks. And if you look at the development time when you do a redesign of a product or have the first idea of a product, it's really, really fast. So the benefits of scripting languages, you all know them. It's easy to learn them. With MicroPython on your first initial board, you get an easy working prototype very quick. So even if you just have to show it off to a customer to get the first proof of concept, you can have this ready in a couple of weeks, except then maybe you do it with C. So the time to market might get reduced through this. What all these development boards and IoT things are about is that it's easy extensible like by a user, so you really want to tweak it your way. So it's easy to do this with a scripting language instead of maybe with plain C, what's traditional in the embedded market. So luckily there are some people who use MicroPython in the product development. So there's one company that came across MicroPython when they were searching for a lightweight Python implementation, but they didn't want to have a full Linux system on their device. So they were firstly going with an embedded Linux system, but they wanted to get rid of all the blown shell scripts that they have to use on the device. And this company, so they made a bold decision at the time because MicroPython was very young. And 2 years later, they actually are now 500 nanoamperes with an active REPL. So this is quite impressive because they are able to do real-time image processing now. So this is one story. And I'm going to tell you a little bit more about the different projects I'm aware of. So there's one project that is still a working project. They are approaching us, and they're looking into it, and they're very excited, and we are very excited too. Then there are prototypes of redesigns from existing products when the actual products reach end of life. And people looking into it, maybe we can do this in a more efficient way, and we're using MicroPython. And they are really new products, like we have a new idea, and we are approaching it. So, and the device I brought here has a successful certification, and it's already in production. So these devices are running in the field 24/7, like with high reliability. So I really want to say that there are real products out there working in the field. Yeah. So when we talk about MicroPython, it's definitely worth, like, he is the creator of MicroPython, so it's George Robotics. And as he has a background in theoretical physics, and he approached the design by a more academic and research-oriented point of view, instead of just simply, I want to fix this problem. And we think that this is the reason why MicroPython is so successful. So the first company I want to talk about is Aqua Power Technologies. It's a UK company. They are based in the Lake District, and they create innovative machines to generate power from marine environments. So if you have a look, they have really, really cool, huge hardware which they put into the sea. It's really amazing. And they are looking into their product called the Aqua Boy. And currently it's logging and collecting data from an accelerometer, how the waves are flowing. And actually now it's using MATLAB, but they wanted to have it on their device, on their embedded hardware. So they were approaching us, so MicroPython team, would this be able to do? And we were saying yes, and we are very excited about implementing this in the next couple of weeks. So this is still work in progress, but it's coming up. Then there is a US company called Travis T Consulting. He's using MicroPython for his product development to make them even more rapid, because he's a mechanical, electrical, and software design engineer. And what he said is like the constant battle of finding components and tools which are easy to use, I still have a professional level, there's kind of a gap, so MicroPython kind of filled this for me. Yes, so he says, as you can see on the left side, this is an adapter board which has the same microcontroller as our Pi board reference board. And he designs his own little boards and plugs it or solders it on his extension boards. Unfortunately, I'm not allowed to say what final product this will be, but this is also used in a real product in the end, yeah. And he said it's so easy that he don't really needs a debugger because he already has the running microcontroller and he don't have to care about this. So he can really focus on how can I connect this sensor, or how can I get the UART working or something like this. And then there's a company, which the prototype I brought here. They are doing manufacturing of monitoring the the traffic on highways, mainly on highways, yeah. So this is a German company based in Hamburg and Dresden. In the market, they are quite small, but they're quite aggressive. And they have the only working solution that has a real certification, like the high-end certification in the market, sorry. Yeah. So on the left side, you see a traffic monitoring and classification system, because there are two problems. You have a lot of vehicles, and they all need to be categorized in some way, because if you want to have new roads, you need to bring reliable data on how is there really so much traffic? Well, I sometimes just have to go to the Autobahn, which is near to me, and I can see it, that there's too much traffic, but yes, you have to have the reliable data. And then there's another problem. There are a lot of overload vehicles, and you not always see them as easily as like in the picture here. So they have this system that's called weigh in motion. So it's basically, you have the road, and there are 3 lines of sensors which can measure the weight of the truck. So when you have your raised overload truck coming from the left to the right, it gets categorized in how much does it actually allow it to weigh. And it's connected to a charge amplifier, and they collect the data in their traffic monitoring system. So this WIM DSP32, I brought with me one of these, and actually I couldn't bring the street and the sensors implemented underneath, but this would be really fun, like driving with a truck here. So I brought this here with the simulators they use in the lab, because of course it has to be tested in the first place before you actually go to the track and spend a lot of money for the drivers, and yeah. So let's see if I can show you. So the device is already running, and it's probably so there's an implemented OLED display, which is only for like visualization, because most of the time this is switched off because no one is actually there and looks at it. But it's really convenient to see that, so there are 2 lines connected, and you get somewhere. You get the number of the line, the weight of the truck, and the categorized vehicle, like they categorize the different kind of vehicles in numbers. And so this is all running, it's all very nice. But if we stop this, you can see actually that there's a PyBoard. Some people have used with the PyBoard, but there's actually a PyBoard running on this device. Like, literally not a PyBoard, it's the microcontroller chip, but it's running MicroPython. So I hope this gets a little bit like this is a real world project. Sorry. So how MicroPython made the difference? Obviously, it was very obvious, because the controller that has to be used was in the beginning actually an F4, which is running on the PyBoard as well, and then they improved it to an F7 because they have to do the 32 A2D channels all in real time in line. So they need to realize the fast real-time response. And what was really easy to implement, for example, when you have these displays or other things, like the peripherals of the things that's on the device, which is not really like a core implement, but to get them connected and put this all together was really easy with MicroPython. So it's the amazing software, isn't it? Like this super great implementation of Damien George. Yes, it is. But let's just say it's also a combination of hardware and software and how easy it is to plug something in. So this, what you can see over here is our new board, which is like half the size of the normal Pi board. And the idea was to have, you probably know these ESP32 chips which you can buy everywhere, but you still have to solder them. So we really want to have something that you can, with a micro USB connector, already plug into your laptop and program it, and which you can really easy put on an adapter board and get ready to start programming. So you can really focus on what's your actual problem to solve and not to program, first get the microcontroller running. So that you can test it separately, which means you don't have to worry about if the actual microcontroller is working. So yeah, the new PyBoard D, it's called. It has more functionality than our PyBoard 1.1. It's only 2.4 grams. It's more power, so it's with a better efficiency. It runs on M7 with 260 megahertz and 256K RAM. So it's really low power consumption, and it's a ready-to-use modules, but still in the size of these ESP32 models you might know. So there's a Wi-Fi and a Bluetooth chip enabled, which are already ready to use. And I wanted to show off a little bit of the data compared. So the PyBoard 1.1, which is the original PyBoard, runs at 168 megahertz, which is comparable to 120 megahertz on the new PyBoard. So when you have them idle, it consumes about 80 milliamps, and if they run, they are at 55 milliamps. So this is quite comparable. But the new board can have up to 260 megahertz, which is about 1.75 times faster than the normal like the first PyBoard. And there you have a power consumption from 34 milliamps, and it runs at 112 milliamps. Light sleep is 500 microamps, and deep sleep with real-time clock enabled is 10 milliamps. And what are quite good numbers is the downloading data to the PyBoard, which is 100 milliamps, around 800 kilobytes per second, and the upload is 1 megabyte per second at about 140 milliamps. So, and then, of course, there are things MicroPython is not so good at, or cannot do it also. If you have really small microcontrollers, it's best you use just traditional C. It's still a dynamic type language, so you really have to get your memory your memory in order with the garbage collection. So if you generate too many objects, so you have to keep that in mind. And if you're going with really large projects, you might prefer an embedded Linux system. So to sum up, what are the pros and cons about this? Well, productivity went up. The traceability, because you have a huge community standing behind that in the open source, which they really dig out the problems, and this is great because you rely on that. The testability went faster because you might have already the running board, which you just have to plug in to your adapter board. It's really easy to port to a controller that has more power, for example. And the licensing was an advantage because the MIT license allows you to use the code, but you can really close what might be your generator, which generates your profit in the end. Yeah, and there's quite good support from the team. Well, not so good, it might be that there are increased hardware resources, but all the upcoming microcontrollers show that we shouldn't really have a problem with that, but sometimes it might be too expensive. And there might be some lack of developer skills regarding the scripting languages, because today you usually have C programmers in the embedded world. So this might be something which needs to be more approached, because they do what they're used to, but they might not see the advantage right away. So I hope you enjoyed the talk. You can find more information on micropython.org in our forum, or if you want to support a MicroPython project, you can buy something, pick something up from the store, obviously, or you can write me an email if you have some feedback. So I hope you enjoyed the talk, and I'm happy to have some questions.
Thank you, Christine. That was really informative. Does anyone have any questions? All right, quite a few. We'll start here.
The examples you gave were mostly around development, trial, small-scale applications. Can you see MicroPython being used for larger scale, higher budget, more critical uses?
Yes, of course.
What sort of thing?
Well, I think there we have the problem. MicroPython is still quite young with the 5 years, so there's no. So what happens in 10 years? Because might be the problem why the bigger companies are still holding a little bit back, maybe. So these are all bold, small companies who see an advantage in this. But yeah, I to be honest, well, the work with the ESA, if some of you might heard of this, I see them in satellites, obviously, at some point, yeah, absolutely.
Hi, hello, thank you very much. And I want to know, for someone who has been dabbling with Arduino and now needs something a little bit more beefy, something a little bit bigger to work, what sort of platform you suggest to go? I've seen that there is this ESP32 that is promising, but I wonder, well, seeing that there are lots of those around, so which is that you would suggest for someone who wants to explore a bit of the embedded worlds with those newer platforms?
Well, yes, you might have seen the official MicroPython has ports for the ESP8266 and ESP32. So they are cool chips, but they are not, well, if you want to explore and don't want to spend a lot of money, go with them. But if you really want to put this one in a real application, I would not recommend it right now. I'm not saying that they won't be there at some point, but they still have too many hardware bugs. But if you want to explore, sure, they might good start with them, cheap start. But obviously, you should buy a PyBot to promote it.
Hello. Can you describe the different sleep modes and what kind of uses they have?
The different sleep modes?
Yeah.
So yeah, when you look into the IoT section, you might have devices which are 99.9% are in deep sleep, and you just send data to somewhere in the 0.5 or 0.1%. So with the light sleep, you can wake up your microcontroller with an interrupt, and with the deep sleep, you have the real-time clock, which needs to be very accurate to wake it up again. So these are just very first measurements, so be patient. I had more, or we should be having more very soon. But yeah, like also like when you have the Wi-Fi enabled and disabled, and yeah.
Any other questions?
Hi. Can you tell me whether MicroPython is sort of true real time, or does it run on a real time operating system? Does it come with an which operating system do you recommend using it with? And can it be deterministic real time in terms of the interrupts if you're trying to build a controller? Deterministic real time in the sense that it could respond quick, within a guaranteed time period in the way that microcontrollers traditionally do.
Yes. So I didn't quite get the question with the operating system.
Well, how does MicroPython work with? Which operating system do you use, or is it an operating system as well?
Well, it's an kind of operating system for your microcontroller.
Right.
But you don't really need an RTOS or anything in between on your microcontroller so you just need to flash the firmware on the microcontroller? Or do you mean the PC where you interact with your device, like how I plugged it in and showed you in the...
Just the microcontroller. Just wondered whether, so MicroPython is all you need on the microcontroller.
Yes, so there's no RTOS or other layer in between, so you can flash it right on it. And
that's great. And it works with interrupts, and would you say that it was what we used to call deterministic real time, which kind of means that it responds to an interrupt? within it. Oh, great. Fantastic. Thank you.
I think
You mentioned that you can use MicroPython with BBC Microbit.
Yes.
Can you use it with Arduino or Raspberry Pi?
There is a Raspberry Pi bare metal port. With Arduino, I'm not sure, to be honest. I don't think so. But it runs on the BBC Microbit. As I know, you're a teacher. Are you using the BBC Microbit? No?
I think we can do one last question on that side, maybe. Anyone?
Just asking, because we've seen some examples of it being used, like with all the data science tools. How easy is it for someone like me, which I'm mostly in the data science and a small little bit in the development side, for me to just start using it in a real-time use, for example, like, or connecting it to a sensor array for any of that use?
Well, I would say it's really easy. So if you want to try this, there's some documentation on our website. You just need to have a board. You can buy one that has already MicroPython flashed on it, or you can flash it yourself. Just see what they are available. So connecting a sensor like an I2C or something, it's really easy to set up. If you're just like dipping your feet into something, like for the very first time. So no worries about that. Should be very easy, straightforward.
Okay, lovely. That concludes our session. We have a coffee break from 11 to 11:20, and then we continue from there. Thank you, Christine.
Thanks.